Okay, so the Chapter 5 review that we see here has a few more types of questions, and it really follows that test very closely. So let's go ahead and go over the review. The first question on your test is going to be a quadratic. There's lots of things we know about quadratics. I'm going to show you one way to solve them, but there's actually multiple ways. So you might end up seeing something that you can do multiple ways. So I'm just going to kind of show you what I think to do. The first thing we're going to do is basically we can do those four things kind of in the same kind of step. It's going to happen very quickly. So you want to remember that the vertex is x is found by using negative b over 2a. So that's the quickest way to find that vertex x. That's also going to give us the axis of symmetry. So the b value, remember our a value is on our x squared, so our a is 2, our b is 3, and our c is negative 2. So if we do negative b over 2a's, we get that our vertex is x is at negative 3/4. Okay, so decimal wise, you're going to use that 0.75. Okay, but the axis of symmetry is at negative 3/4, and the vertex is x is negative 3/4. So we get a lot of things very quickly. Now, anytime you have an x of a function and you want to find the y of that function, you know, that the corresponding y, you just got to plug it in. So if I plug negative 3/4 in, it's going to be 2 times negative 3/4 squared plus 3 times negative 3/4 minus 2. You will be allowed to use any type of graph or any type of calculator on the test except for a graphing calculator. So feel free to use one of those red ones in the back. And we get a value. It is negative 3 1/8. Now, negative 3/4 is negative 0.75. Negative 3 1/8. That should say an eighth, I'm sorry. Is negative 3.175 or 125. Okay. So let's talk about the vertex form, and is the vertex a minimum or a maximum? We know if the lead term is a 2x squared, that our parabola is pointing upward. So this point here is a minimum. So all you have to do is say that's a minimum. Okay. You can put min or max. That's all you got to do. Now let's talk about vertex form. We know that the a is 2. That's the same a value in the quadratic formula in the negative b over 2a. A is 2. HK is our vertex. In this case, that's that negative 3/4, negative 3 1/8. Sorry I didn't make this problem have a very nice vertex, but we're good to go. Okay, so what is vertex form? I'm going to put it down here. You put the a, and then it's x minus h squared plus k. So just plop those values in. So our a is 2, our h is negative 3/4. Now we're subtracting h, or taking the opposite of h, so that's going to become a plus 3/4. And then our k just is what it is, so it's minus 3 1/8. Now, if you are a person that didn't use mixed numbers, and if you call that 25 over 8, that's perfectly fine by me. So vertex form, you'll need to know that formula by heart. F of x is a times the quantity of x minus h squared plus k. You're going to put your vertex here and here. This one changes sign, that one does not. That's vertex form. So all of those 4 steps, A, B, E, and F, always go together. So they'll always kind of be answered relatively quickly. Okay. Now let's go ahead and talk about the x-intercepts. Remember, the x-intercepts are where you set the function equal to 0. Now, you can use slide and divide on that one, but however you go to factor it, it is a factorable quantity. You're going to put your 2x in x. You're going to put a plus 2 here and a minus 1 there to make the foiling, the distribution work. Okay, so we have x-intercepts when 2x minus 1 equals 0 and x plus 2 equals 0. Now, those are pretty straightforward how to solve those. If we move the 1 over, we just divide by 2. So anytime you have a coefficient on your x, you're going to get a fraction. And then here we have negative 2. Now, the y-intercepts are a little nicer. You just plug 0 in. So here's our function. So let's just plug 0 in. And it's always going to end up being this constant at the end. And so we get 2 times 0 is 0, 3 times 0 is 0, minus 2. And that's why you end up getting that constant on the end. So that's our x and y intercept. So our x-intercepts are the point 1/2, 0, negative 2, 0. And our y-intercept is the point 0, negative 2. Now, before we actually do domain and range, I would probably hold that till the very, very end. We're going to do domain and range after we have the graph, because then that's going to answer those questions for us, okay? So the best way, I think, to graph a parabola is let's put on our vertex, let's put on any intercepts. If we need more points, you always have a function, you can plug in more points, you always have that power, okay? So let's go over to our graph paper. Put on an x and y axis. Doesn't matter where, just put it on wherever. Now, you may recall we have a vertex, you can see right there, at negative 3/4, negative 3 1/8. So we're just going to guesstimate. And so here is an x value of negative 3/4, you know, that 0.75. And then just count down 1, 2, 3, and then just go just a touch more. So I think it would be about right there. So just guesstimate. Now here's how you can tell if you got the vertex right. We had x-intercepts at 1/2 and negative 2. So if you put one at negative 2 and you put one at, at negative 2 and 1/2, when you put those on, do you see how our vertex is smack dab in the middle of them? That's how you can tell that you got all those things right, because that won't happen just by chance. If you have the axis of symmetry on there, it goes through the vertex. We'll put a little V for vertex. It should always be smack dab in the middle of any x-intercepts you may have. Now, if you don't have x-intercepts, then you got to plug in some points. Okay, now our y-intercept was at negative 2, and that makes sense, as we can see. Okay, so let's graph our parabola. And so everything kind of fell in place, right? Everything kind of worked the way that you wanted it to. Now, the only question we haven't answered on this whole thing is the domain and range. The domain are what x values am I allowed to plug in? How does my graph stretch from left to right? What's great about the domain of any parabola, it's always the same. It's always from negative infinity to positive infinity. There is no differentiation from that because of the fact that nothing messes it up. You can plug in whatever the heck you want. Now, the range is always determined by what you said right here and this vertex point. If it's a parabola that goes like a U, there's always going to be a lowest value, the minimum, and it's going to go up to infinity. Now, if it's upside down, so if it looks like an upside down U, then it's going to kind of do the opposite thing. The lowest value would be negative infinity, and you would hit that vertex as your maximum, okay? So our range has a lowest value, whatever the y value is that we hit, that -3 1/8. And it is a point on our graph, but we can keep going forever and ever and ever and ever and ever after that. So that is everything you're going to need to know about a parabola. Okay, so the first question on the test is a parabola. Do we have any questions about what we see here? Anybody have any questions about the first question on the test? Anybody have any questions? Okay, so the first one is a parabola. The second question on the test will be to graph a polynomial. Now, up on the board to your left, I'm always going to kind of give you the good order to go in. My questions kind of follow that order, but you see how for graphing a polynomial, I just said, what is the lead term doing? Find the end behavior, get it in factored form so you can find the x-intercepts and y-intercepts, and then you're ready to graph it. And that's kind of what we're going to follow. And that will be sitting up there. There's some formulas. The quadratic formula is going to be up there. The a squared minus b squared, a squared plus b squared, all those formulas. I'm going to leave what's up there. Okay. So factored form is really important, but I would probably kind of go even in that order. Let's find the lead term and the ends first. Well, the lead term is our highest powered term. That's that term right here. That x to the fifth is very powerful. It determines what our ends are doing. So it's going to look on the end like a cubic. The left end's going to go down. There might be some bumps, and the right end's going to go up. So you can say left end to negative infinity and right end to positive infinity. You can draw me the little graph. You can say the words, however you want to do it. Yes. Oh, I sure the heck am. Oh, thank you. Luckily, hopefully we can move it. Oh, there we go. Thank you. Yeah. Okay, so your left end's going down like a cubit on the left side, and the right end will go up. So kind of think about that first, because that's really going to give us how that behavior of the graph acts. The next thing we have to do is get it into factor form. Okay, so you may notice that this polynomial does seem to follow the grouping sort of thing. Remember, if there are 4 terms, there seems to be a pattern. So if you're good at grouping, you can do that. That will also work. But one thing I noticed right off the bat is that every single one of those things has an x, and the lowest power is an x squared. So why not do that very thing first? So you'll notice I took out an x squared because of the fact that every single thing had a common factor. So if it has a greatest common factor, always remove that first. Okay, now if you know how to group, you can use grouping on that piece. But let's call this piece, I'm going to call that g of x. And I am going to plug things in and hope that things happen. Well, I made this problem, so I'm going to plug in 1, and let's see what happens. If you plug in 1 for all of the x's, you get 1 plus 1 minus 4 minus 4. Doesn't work. But watch if we plug in negative 1. We get negative 1 plus 1 plus 4 minus 4, which indeed is 0. So remember, as soon as you find a 0, you get to use division. This tells me that the opposite of that goes into that parenthesis. You remember it's x minus the 0, so that becomes x plus 1. That's a factor. So that means we got to take that out. Now you can take that out using long division or synthetic. I tend to go synthetic, so I'm going to put negative 1 in the corner. I'm going to use my coefficients. Remember, I'm only trying to break this piece up. That x squared's just, it's there. It'll be there later. Okay, 1, 1, -4, -4. So set up your synthetic division box. Set up your synthetic division box. That's what I've done right there. Once your synthetic division box is set up, you're just ready to plop that stuff in. So you multiply, write it down, add them up. Multiply, write it down, add them up. Multiply, write it down, add them up. You should get a 0 in that corner. If you don't get a 0 in that corner, something is wrong. When we plugged it in, I just am using the coefficients here. Yeah, that's okay. Use the coefficients there. Okay, so what do we got? Well, if we put our x's back in, remember that's a cube. So this is where squared starts. So we have x squared plus no x minus 4. Now let's think about what we got. From our original function, we took out an x squared. We found an x plus 1. Now we found an x squared minus 4. Is that a factorable thing? Is x squared minus 4 factorable again? If they're both perfect squares and a minus between them, up on the board will be the formula, but that's just the difference of squares. So we have found the complete factored form. Just make it x plus 2 and x minus 2. So that's great. We've got all those pieces, and so the factored form is going to go up on this line. And your factors and my factors don't have to be in the exact same order, as long as all of them appear, okay? Now what's great is that factored form gives me my x-intercepts. The x-intercepts are completely dependent upon my factored form. It's just, where is x squared equals 0? Where is x plus 1 equals 0? Where is x plus 2 equals 0? Where is x minus 2 equal to 0? Where are all those things equal to 0? So we get 0, -1, -2, and 2. So put those on the list. Those are our x-intercepts where each factor equals 0. Now, I don't know why I said bumps, bounces, but let's just concentrate on the bounces. That's all you got to put here. What is the only factor that had a power on it? What's the only one that had a power on it? Yeah, the x squared. And that's an even power. So that means that's the only one with a bounce. So you can say there's a bounce when x equals 0. So bounces kind of go with your x-intercepts, and if you have any even powers on a particular factor, that's going to be where your bounce is. And then y-intercept's a little different. It's nicer. You're just going to plug in 0. You get 0 plus 0 minus 0 minus 0. You get 0. So if an x-intercept is 0, that should also be your y-intercept. And now we're ready to graph it. Now what's nice about this is usually you don't have to plug any points. You have the power to plug in as many points as you want. Okay, but I think we are ready now to graph it. This is one where if you have to adjust your y-axis, to count by 2s or count by 5s, sometimes those y values can be very large. The one I just did, that wasn't an issue. It is what it is. But if you have to adjust your x or y axis, like if you want to count by 2s or count by 5s, feel free to do that, but just let me know, okay? Make sure you mark your x or y axis where you do that. Okay, so let's put on our x-intercepts. We have 1 at -2, at -1. We have 1 at 0 and at 2. So always put on your x-intercepts first and any y-intercepts. So those are actual points that we have to touch. There was the y-intercept and the x-intercept are both 0. Okay, next thing you always put on are your ends. The left end's going down, the right end going up, and they always come off of the widest, the furthest out x-intercepts. So whatever those happen to be. Now remember, we're going to go through every point, make a bump, come back down, except at 0, we got to bounce. Okay, so what does that mean? So we're going to go up, through, bounce. Now when you're bouncing from below, it just means it bounces and comes back down. And that's what our graph looks like. That's as accurate as your graph has to be. I don't care if you put the bumps in. You know, if your bumps look a little lower or higher than mine, I do not care. So let me go through it again. We're going to go through, bounce, through. Yes.
How do you figure out whether it's like whether the left end is positive or negative infinity, and whether the right end is positive or negative infinity?
So always remember that if we have a odd power, okay? So remember, odd power, it acts like a cubic. If the front coefficient is positive and the lead term odd power, you're going to look like that. If it's a negative coefficient, it's going to go like that, okay?
So it's just whether or not it's positive or negative.
So if it's an odd, the highest power is odd, it acts like a cubic, and the ends act like just exactly like the cubic does. One up, one down. If the lead term has an even power on it, it acts like a parabola on the ends. Both go up if the coefficient is positive, both go down if the coefficient is negative. So just use that lead term, whether it's odd or even, will get you everything you need about what the ends are doing. Okay? Any other questions about our polynomial that's going to be on our test? Any other questions about the polynomial? Okay. So that's polynomial stuff. Now let's talk about the lovely, wonderful rational function. Now I have not given you a rational function with a slant. I'm not going to give you one with any holes. So ours will not be a slant or holes, but we will follow the steps that are up on the board, and I will have those as a little reminder up on the board. So you want to get it into factored form. I did not make this one factored one. I think the one on your test is a similar setup to the type you see here. So because there are no matching factors on top and bottom, that means there are no holes. And again, I'm going to keep mine like that. So instead, we jump to vertical asymptotes. So the vertical asymptote, remember, is where the bottom equals 0. So it's just going to be where x minus 2 equals 0, or at 2. So I would go right to my graph paper, and at positive 2, put that on there so that you don't forget it, okay? So if you'll notice up on the board to your left, it says factor it to find any discontinuities, those holes or vertical asymptotes. And then once you found holes in vertical asymptotes, we are actually ready to do the domain. So I would go to the domain part, not the range, but the domain. So the domain is what values did I skip? What are the discontinuities? So the discontinuity is only at 2. We only had a vertical asymptote at 2. So go to our graph and skip 2. We'll come back to our range. We really need to see the graph before we do range. Range is our last thing. Our x-intercepts, as long as it doesn't have a plus or minus number on the outside, is always where the top equals 0. So x plus 1 equals 0 when x equals negative 1. Y-intercepts are just plugging in 0. If you plug in 0, you get 0 plus 1 on top, 0 minus 2 on the bottom, which is negative 1/2. So that's a pretty straightforward thing. So all those things can be done pretty quickly. The one that throws people off sometimes is the horizontal asymptote. Now, if the bottom factor is more than the top, it's always going to have a horizontal asymptote at 0 because you keep dividing by bigger and bigger numbers, and so it ends up getting closer and closer to 0. But in this case, we have a coefficient on top and a coefficient on the bottom that we have to use because the power on the top and the power on the bottom match. So the coefficient on top is 1. The coefficient on the bottom is 1. So it's just 1 over 1 or 1. Let's put that on there. So if the power on top matches the power on the bottom, it's always y equals the coefficient on the lead term on top over the coefficient on the lead term on the bottom. So next thing I would do, we're kind of ready to graph it. If you have an x-intercept or a y-intercept, let's put that on there. We have an x-intercept at -1. We have a y-intercept at -1/2. So that kind of tells us, remember, those lines kind of trap us in a way. We have to head to that, and we have to head to that. So we have this piece kind of just naturally. Now, if we didn't have values in this area, I would probably plug in some extra points. I don't need them. As long as you have 2 points in a region, you're usually good to go. But I sure the heck don't have any points over here of values that are to the right of 2. So I'm just going to plug in 3 and 4. Let's see what the heck happens. Because I will either find a piece up here, which is pretty common to be a kind of across the x, or maybe I got a piece down here. Okay, that usually happens if you have some powers. It might happen. Anyway, let's plug in 3. If you plug in 3, you get 4 on top. You get 1 on the bottom. That's 4. So over at 3, I'm up at 4. If I plug in 4, I get 5 on top and 2 on the bottom. That's 2.5. 5 halves is 2.5. So at 4, I'm at 2.5. So this piece looks like it's trapped here. And if you're unsure, you have the power to plug in points. You can always plug in more to verify your shape is doing what you believe it's doing. So that is the third thing that's going to be on the test. The last thing we haven't done, though, is range. The only value we have skipped is what y value? What y value are we not going to hit? Positive one. We're not going to hit that horizontal asymptote. So that one means we go up to a y value of 1. We jump across that y value and keep going. We have stuff here. We jump across it. We have stuff here. So we have every y value except for 1. And the one I gave you is going to have a similar kind of quality to it. So that is your rational function. Okay, so now let's look at number 4. It says write an equation with zeros 1, 2i, and -2i, and that goes to the point 0, -8. Okay, so what we're going to do is this. First thing you have to remember is you're going to have to memorize the template. It's a times the quantity of x minus the 0 times x minus the 0, however many of those you need. Okay, so first off, just write f of x equals a times x minus 1, x minus 2i, and x plus 2i. Okay. Now for this to work properly, the 2 i's can't be there. Meaning if we take and we multiply the conjugates, these are conjugates, if we multiply those, the i's will disappear. Now, if you look to the board on your left, there is a formula that has i's in it. Those always multiply and give me something actually pretty darn nice. That ends up being x squared plus 4. Now, you were told in Algebra 2, probably, and Algebra 1, that x squared plus 4 is not factorable. Well, it's not factorable for the real numbers, but it is for the imaginary numbers. So I always just try to get that into your head, that x squared plus 4 factors to be x plus 2i and x minus 2i. So it's just a good fact to know. But just stop there. Don't go further. And now we're going to need to use the point 0, -8. We need to find the a value. Once we know the a value, we're ready. So remember, this is your x. This is your f of x. So f of x is equal to 8 when x is 0. So that would be 0 minus 1, and that would be 0 plus 4. Well, 0 minus 1 is -1. 0 plus 4 is 4. Now, if you forgot to do this piece, you would get a -2i times a positive 2i, which ends up being 4 anyway. So even if you don't do that piece, you'll still get it to work. And then you end up something nice. You get 8 equals -4a. And to solve for a, just divide everything by -4. So a is -2. Now, as soon as we get that, yes? Because Mrs. Hott can't read. That's -8, that's -8, that's +2. Thank you so much. Oh my goodness gracious, okay. I thought I was doing so good too. Okay, anyway, so now what do we have? We have this general formula we found. We know the a value. Put that information together, we got it. So f of x is going to equal, here's our equation, 2 times x minus 1 times x squared plus 4. Now, I don't care about you multiplying it any further. I'm pretty sure you know how to do that multiplication. You know, you would put 2 in here, then you would distribute again, you know. Okay. And then the last things we have are the intercepts and division. So 5 says to find the x and y intercepts. To find the x-intercepts, I was nice to you, it will be already in factored form. Yeah.
So is x squared plus 4 when you factor it out? That is it just when you factor out an x squared plus something, would that just be the same as when you do it normally, but you put I on both of them?
Exactly. Yeah. Yeah. And I have that right there for you. I'll keep it right there, so you can have it. Okay. But yep, that's exactly what happens if you have a plus x squared plus 4 factors and uses the i's. Okay. So for number 5, to find the x-intercepts, since it's in factored form, remember you're just going to set x minus x equal to 0, x minus 1 equal to 0, and x plus 3 equal to 0. And so you get x-intercepts of 0, 1, and -3. Okay. So those are the x-intercepts, so that should be nice. Remember your y-intercept, you're just going to plug in 0. So you get 0 times -1 times 3, which is 0. Remember, if the x-intercept is 0, you're going to get a y-intercept of 0. And then finally, there is going to be a division problem. I have not specified what type of division you do. So you decide what kind of division you want to do. It doesn't matter to me. You can use long division. You can use synthetic division. I have set it up, I believe, so you can use either. Let me just kind of peek and I'll tell you. Yeah, so you can use either form. If you like long division, go for it. If you like synthetic, go for it. I'm going to use synthetic. So you're going to set x plus 1 equal to 0. You're going to get -1. You're going to put -1 in the corner. Now check your coefficients or your powers so we can use the coefficients. The powers go 3, 2, 1, 0, perfect. If anything is missing, make sure to put a 0 in there. Now we're going to pull out the coefficients in order, descending order, 1, 2, -5, -6. Okay, so now we're ready to go. We're going to multiply. Write it down, add them up. We're going to multiply. Write it down, add them up. We're going to multiply. Write it down, add them up. I didn't necessarily make them 0 remainder, so make sure to include the remainder if it happens. This one does have a 0 remainder. Now remember, our x was a cube, so this one, it goes down a power. So I like that arrow. It tells my brain two things. I'm going to bring down the coefficient. I'm going to bring down the power by 1. And so your final answer would be x squared plus x minus 6. Don't just leave it here, 1, 1, -6, without taking the time to put the x's on, because it's not right until you put the x's back in. Okay, so that looks very much like the test. The best way to study for a math test is to do math. The best way to study for a math test is to repeat the process. Can you do it again? Can you repeat it again? If you can repeat it again without looking at me do it, you're ready. If you can't repeat it again, you're not ready. Okay? So my suggestion was you can go back into Google Classroom and get 5 blank copies of this if you want it. You can watch the video with it again. I'll post the video later today. You can do it with the video, do it without the video, but you're going to have to study and know all those formulas and recognize what to do with each step. If I ask for a y-intercept, do this. If I ask for an x-intercept, if I do this. If I say, what are the ends doing? You got to know those things. The math itself, you saw, it's not particularly difficult, real difficult, the math. But what's difficult is recognizing what to do, and that will only come if you study it. So please take some time out of your life today and study it, okay? So the test will be tomorrow. I'll give you 2 days to do it because this stuff takes a while, as you can see. So do we have any questions? Yeah. I did not split it necessarily into 2 parts. I just have a front and a back. You'll start it tomorrow, and then you'll finish it the next day. Yeah. Any other questions? Okay, there you go. Oh, turn this in right now so that you don't lose the points. You did it. Turn it in where it says review number 2.